Hey everyone, this is Etchi working with Alexia, and our math project is on Poiseuille's law. Poiseuille's law describes the flow of fluids through a cylindrical pipe, and clinicians use this to determine the amount of fluid delivery in IV administration and airway resistance. The formula used to describe this law is Q equals pi times P times r to the fourth divided by 8 times N times L. And then the Q in this equation is the flow of the fluids. And then our next variable is r, and r is the diameter. Next, we have the P, which is the pressure of the tubing. And then we have L, which is the length of the substance. And lastly, we have N for this viscosity. Okay, now we know what the formula is, but now we ask ourselves the question, where does this formula come from and how exactly do we derive it? In order to give a visual representation of the law, I'm going to be drawing a cylindrical pipe with a fluid in it and two opposing pressures at the ends. And this pipe can mimic a blood vessel, a catheter, or anything of that sort. And then right now I'm going to be labeling the length for L, and then the distance from the center, which is R. And then on this side I have the driving force due to the pressure difference, and then on the other end I have the viscous drag force, which opposes motion. Now we'll be going into more detail about the two opposing forces. The first one is the force of pressure, which is the change in P times pi times r squared. And the next one is the force of viscosity, which is also known as the drag force. And this is negative N times 2 pi times r times L times dv over dr. And then what we'll be doing is taking the force of pressure plus the force of viscosity and setting it equal to 0. And we do this because in an equilibrium condition of constant speed, the net force goes to 0. Since we now know what the force of pressure is and the force of viscosity, we can plug in those values into the equation, and we can solve for dv over dr. What we're going to do is add the force of viscosity to both sides, and then we're going to be dividing by n times 2 pi times r times L, and we are going to get dv over dr equals a change of P divided by 2nL times r. From here, an integration can be made to get an expression for the velocity. And what we'll have is the integral from v to 0 dv equals delta p over 2 times n times L times integral from little r to big R of little r dr. And then we'll have v of r equals change of p over 4 times n times L times big R squared minus little r squared. Now the equation of continuity given the volume flux for a variable speed is dv over dt equals the integral of v times dA. Substituting the velocity profile equation and the surface area of the moving cylinder, we now have dv over dt equals the integral of v dA, which equals the integral from 0 to big R of the change in P over 4 times n times L times the quantity of big R squared minus little r squared times 2 times pi times r dr. And then from there we'll get pi times the change in P divided by 2 times n times L times the integral from 0 to big R of big R squared times little r minus little r cubed dr. And then we'll get pi times the change in P divided by 2 times n times L times r to the fourth divided by 2 minus r to the fourth divided by 4. And then from here, we're going to get pi times change in P times r to the fourth divided by 8 times n times L. And then we get dv over dt equals pi times change in P times r to the fourth divided by 8 times n times L. And voila! Now that we know what Poiseuille's law is and how to derive it, let's tie everything together and solve an example. The flow of blood through a large artery extending from heart to lungs with a radius of 2.5 millimeters is found to be 15 centimeters long. If the pressure across the artery is found to be 380 pascals, what is the blood's average speed? So what we have given is the N, which is the blood viscosity, which equals 0.027 newtons times seconds per meter squared, And we have that the arterial radius is 2.5 millimeters, and the difference of pressure is 380 pascals. Now what Alexia is doing is rewriting the formula for Poiseuille's law, and it's Q equals pi times the change in P times r to the fourth divided by 8 times n times L, and we are going to be plugging in the numerical values we have into the equation. So we'll have 380 pascals times 0.0025 squared divided by 8 times 0.027 times 0.10. And once you do all the math, the average speed becomes 1.09953 meters per second.
Thank you for watching. Please like and subscribe for more.